We will be looking at lesson 9.2 in our statistic chapter, and this is about variability. So let's go ahead and take a look at this. So first we're going to go ahead and explore variability, see what this is even talking about. So we're going to have three sets of data, three lists of data, our set A, set B, and set C. And you can take a look and see them there, just 5 things in each set. If we did some examining for this set, we would see that the mean and median are 6 for each of the sets, but realize they're not the same set. So something's different about them. So we can't just go by mean and median and say what type of set it is. And the difference is that the numbers are spread out differently around the mean. So the mean is 6 for each of them, but they're spread out differently. And we are going to be studying the spread in this lesson. So first let's talk about the range. Range is a way to see how spread out some data is. So the range is the highest value minus the lowest value. And so we can look at the range for each one of these sets. The range for A, set A, is 8 minus 4, which is 4, so the highest minus the lowest. The range for set B is 10 minus 2, so that range is 8. And the range for set C is also 8. So we see that sets B and C are spread out a bit more, but they're still not exactly the same. So we're going to look even more at the spread. So we're going to talk about deviation. The deviation talks about a specific data value. So the deviation of a data value from the mean is the difference between the data value and the mean. So whatever data value you're talking about, you're going to take that and subtract the mean, and that tells you the deviation. To deviate is to be different than the norms. That's why they use this term deviation. It's how far a data value is from the mean. So taking a look at our sets, we know that the mean is 6. So we see in each set we have 8. So this data value 8 minus the mean of 6 is 2. And then 7 minus the mean is 1. 6 minus the mean is 0 because the mean is 6. 5 minus the mean of 6 is -1. And 4 minus the mean of 6 is -2. And we can look at that for each list, and we see the deviation for each data point. If we were to add up all the deviations, we would get 0. The deviation can tell how far a data point is from the mean, but it doesn't really help us with the spread by itself, but we're going to go ahead and use the deviations to help us find the spread. So the first way is called mean deviation. What we do is we take the absolute value of each deviation and then average that. So we can take the sum of all our deviations, the absolute value of our deviations, and then divide by however many values there are, divide by our sample size. The mean deviation actually is not a very useful statistic, so we have a better one, and that is variance. So variance is the averages, it averages the squares of the values of the deviations. So what we would do is we would square each deviation, add all of those up, and then find the average of them. So the parameter of variance, we use sigma. This is a lowercase sigma here. Sigma squared is the variance, so that's odd that we're calling variance actually something squared, but we'll see later that the square root of this, just sigma, is an important value for us. So the parameter of variance is sigma. This is for the entire population, sorry, sigma squared. And you see here that this is the deviation squared, and then we're going to sum those up, and then you would divide by how many how much is in the sample size. And then for statistic, we use S squared for the variance, and once again we see the data point minus the mean, so this is our deviation squared, and we add all those up. And In fact, we actually don't divide by n. We don't divide by the sample size. We divide by n minus 1. So a little bit different there, but that is variance for a statistic, so for the sample. The sum of squares is an important term, and we'll see that a lot, so we actually give that the abbreviation of SS, and we do use capital S, capital S. That represents the sum of squares, so that's this numerator. We're adding up all the squares. So let's take a look at variance for list B and C. Those were the ones that had the same range. So if you notice here, well, first notice that our X bar got off. This should be above the X for each of these. That's supposed to be the average. So that bar is supposed to be above the X. I apologize for that. We have the deviation of each data point. That was the X value minus the mean. And then what we do is we square the deviation. So 4 squared is 16, 2 squared is 4, 0 squared is 0, negative 2 squared is 4, and negative 4 squared is 16. And then you see these deviations as well. And then the sum of squares, SS, you just add all of those squares. Deviations up, which is 40 for set B, and it is 32 for set C. And that is not the variance yet. That is the sum of squares. So to find the variance, we are going to go ahead and divide by n minus 1. So we have 5 data points, so we're going to divide by 5 minus 1, which is 4. So we're going to do 40 divided by 4, which is 10. So our variance for set B is 10, and then our variance for set C is going to be the 32 divided by n minus 1, which is 8. So that is variance. And so that gives us, that's the first thing that was kind of different for us. The mean was the same, the median was the same, or range was the same, but the variance is different. And we're going to go one more step, and we're going to find the standard deviation. So the standard deviation is the square root of the variance. So we found the variance was S squared for a sample size, or sigma squared as the parameter. But we're going to take the square root of that, and that is going to be our standard deviation. And the standard deviation is important because it kind of normalizes everything for us. It helps us see how spread out something is. So it's the most useful calculation for measuring spread. So in our sets that we were talking about, set B had a variance of 10, and you take the square root of that, and the standard deviation is 3.16. And for set C, the variance was 8, and the standard deviation was the square root of that, which is 2.83. So we see that set B is more spread out than set C. So let's go ahead and do an example of this. You are using this. It says find the sum of squares. That capital S means the sum of squares. S squared, so I typed that incorrectly. That's supposed to be S squared, so that's looking for the variance, and then S, the standard deviation for this data. Now this data is apparently a sample because we're using S squared and S as opposed to sigma. Now they kindly put these in order from smallest to largest, which doesn't have to happen, but it's helpful. So in order to do this, to find the sum of squares, we think, oh, it's just asking one small thing, but there actually is a little bit of work you have to do to get there. So we definitely need to find the mean of this data. So you would add them up and divide by how many there are. 1, 2, 3, 4, 5, 6, 7, 8. So here is the list of data: 23, 29, 34, 37, 40, 41, 43, and 51. If you add those all up, it's 298. And so our mean is 298 divided by 8 is 37.25. So the mean, which I should have had on here, is 37.25. And so to find each of these deviations, you take 23 minus the mean, which I just mentioned was 37.25. 29 minus 37.25 is negative 8.25. 34 minus 37.25. So we have all of our deviations. You don't need to know the sum, but we did learn that the sum of the deviations would be 0. Now we're going to square each one of our deviations because our goal here to begin with is to get the sum of squares. So we have to square each one of these. And so you could go through with a calculator and square each of those, and you would get these values. And then you could add all of those values up, and you get your sum of squares. So 525.5 is the sum of squares. Now to find s squared, that is the variance. So s squared is the sum of squares divided by n minus 1. So we had 8. Our sample size was 8, so we do 8 minus 1 is 7. So 525.5 divided by 7 is 75.07. That is the variance. And then we want to find s, the standard deviation, so we take the square root of the variance, which is the standard deviation, so the square root of 75.07, which is 8.66. So the standard deviation for this set is 8.66.